To understand the difference between the PV diagram of a CNG engine and a diesel engine, we need to look at how the combustion process is triggered. Okay, diagram of a CNG engine, which follows the Otto cycle, and diesel engine follows diesel cycle. Okay. Number one is CNG engine, the Otto cycle. CNG engines are spark ignition, SI engines. The fuel and air are mixed before combustion, and a spark plug initiates the reaction. So you can see a stage of the diagram. Number one, intake stroke. The piston moves down, drawing in air-fuel mixture. Pressure remains roughly atmospheric. Number two, compression stroke. The piston moves up, compressing the mixture. The pressure rises exponentially. In CNG engines, the compression ratio is relatively low to prevent knocking. Okay. And three, combustion, constant volume process. This is the most critical part because the spark ignites the pre-mixed gas almost instantly. The combustion happens so fast that the piston hasn't had time to move yet. In diagram, you see vertical line over speed rise. This represents V constant. And the pressure jumps instantly from low to very high. Number four is expansion power stroke. The high pressure gas pushes the piston down, performing work. The pressure and temperature drop gradually. And number five, exhaust stroke. The piston moves up to push out the burnt gases. So summary of pressure behavior: sudden, sharp, nearly instantaneous pressure spike at a constant volume. So, let's go to diesel cycle. Diesel cycle are compression ignition engines, CI engines. They compress only air and fuel is injected into the hot air late in the cycle stage of the diagram. We can see at first intake stroke, only air is drawn into the cylinder. Number two, compression stroke. The piston compresses the air to a very high ratio. The pressure and temperature rise significantly. Diesel engines have much higher compression ratios than CNG engines to ensure the air gets hot enough to ignite the fuel. And number three, combustion, constant pressure, rate process. Unlike CNG, fuel is injected gradually as a piston begins its downward movement. Combustion is not instantaneous. It continues as a fuel is sprayed. In diagram, you don't see a vertical line. Instead, you see a slope line during the combustion phase. This represents the fact that pressure is rising while the volume is also increasing and P is constant, or a gradual rise during expansion. Number four, expansion power stroke. Once all fuel is burned, the remaining energy drives the piston down. And exhaust stroke. Number five, the exhaust gases are expelled. So summary of pressure behavior in diesel cycle: a gradual, controlled increase in pressure that occurs while the volume is already increasing. And comparison table, why do they differ? You can see features: ignition type, combustion mode, diagram shape, compression ratio, fuel injection, and you can see differences between them in diesel engine and CNG engine. For example, ignition type in diesel engine is compression ignition, but in CNG is spark ignition. Combustion mode is constant pressure in diesel, and cycle in CNG engine, constant volume we have. So diagram shape is a slope line in diesel, and in CNG or Otto cycle, vertical line. And the same way, you can see other differences. So the fundamental reason for the different shapes in PV diagram is the timing of energy release. In CNG, the energy is released all at once due to a spark. Because the energy release is faster than the piston's movement, the volume doesn't change during the heat addition, vertical pressure spike. In diesel, the energy is released as the fuel is injected, since the injection takes time and happens while the piston is already moving down. The volume increases during the heat addition and gradual pressure rise.